Hello everyone, welcome back to my channel. In this video, we are going to talk in detail about hematopoietic cytokines and growth factors. Okay, hematopoiesis is regulated by a variety of cytokines and the growth factors, many of which are secreted by the cells of the bone marrow microenvironment. These include macrophages, endothelial cells, fibroblasts, and adipocytes. The bone marrow microenvironment also includes the extracellular matrix, which may be critical for binding cytokines to facilitate interaction with hematopoietic cells. Growth factors can work singly or synergistically with other cytokines. Okay. The effect of hematopoietic growth factors are mediated by binding to the specific receptors and activation of intracellular signaling pathway to promote cell proliferation and maturation. We are going to see some of the important cytokines and growth factors that are involved in hematopoiesis in this video. First, let's start with erythropoietin. So, erythropoietin has the role in erythroid and megakaryocyte progenitor growth and differentiation. This is why we give erythropoietin to non-regenerative anemic patients. Okay, and you have thrombopoietin. Thrombopoietin is going to increase the production of megakaryocytes and platelets in the bone marrow. And third, importantly, you have granulocyte macrophage colony stimulating factor. This is going to enhance the growth and development of multipotent myeloid progenitors. And it also stimulates the production of neutrophils, eosinophils, basophils, and monocytes. It also primes the phagocytic and chemotatic function of granulocytes and monocytes. Coming to the granulocytic colony stimulating factor, which is called as GCSF, it enhances the differentiation and activation of neutrophils. And coming to the monocyte colony stimulating factor, monocyte or macrophage, it helps in growth and differentiation of both monocyte and macrophage. Macrophage is developed from monocyte, and monocyte colony stimulating factor plays an important role in it, and it also increases the phagocytic and secretory function of both monocyte and macrophage. Monocyte is commonly present in the circulation, macrophage is present in the tissues and connective tissues. Now you have the most important growth factor, that is stem cell factor, otherwise called as SCF. It acts synergistically with various growth factors to stimulate myeloid, lymphoid, and erythroid progenitors. Because it is a stem cell factor, it is going to enhance all the stem cells to differentiate and produce. It also stimulates the proliferation and maturation of mast cells. Okay. Now coming to the interleukin family. Inter means in between, leukin means leukocytes. So between leukocytes, these interleukins acts as a message between leukocytes. So coming to the interleukin 1, it induces expression of multiple cytokines. Okay, and it especially acts synergistically with interleukin 3 in stimulating the proliferation of hematopoietic progenitor cells, and it also induces the synthesis of acute phase reactants. And coming to the interleukin 2, it enhances the proliferation and activation of T cells, B cells, and NK cells. This interleukin 2 is dedicated for lymphopoiesis. Okay, and coming to the interleukin 3, It enhances the production and differentiation of macrophages, erythrocytes, neutrophils, eosinophils, and basophils. And now we have interleukin. As you can see, I have drawn plasma cells. So its main effect is to increase the antibody secretion by B lymphocytes, okay? And it also has diverse effects on T cells, monocytes and granulocytes. And also it acts synergistically with erythropoietin, sorry I have written it wrongly, erythropoietin, granulocyte macrophage colony stimulating factor, and granulocyte colony stimulating factor. And coming to the interleukin 5, you can see eosinophils. So its main effect is going to be on eosinophils. It is going to stimulate and differentiate the growth and differentiation of eosinophils, and it also increase the chemotactic activity of eosinophils, and it is going to activate or enhance the eosinophil function. And coming to interleukin 6, is going to stimulate the hematopoietic progenitor cell and enhance the maturation of megakaryocytes and eventually increasing the platelet number. It's also going to enhance the production of acute phase reactants. And coming to the interleukin 7, this is also just like interleukin 2, it is committed to lymphoid lineage. So it's going to enhance, it is going to play a major role in the lymphocyte maturation, all the T cell, B cell and natural killer cell. It's going to help B and T cell in maturation and development, and is going to help in differentiation of multipotent hematopoietic stem cell into lymphoid progenitor cell, and it's also going to increase the natural killer cell survival time and help in its development. Coming to the interleukin 8, it's dedicated to the neutrophil, that's why I have drawn this. Is going to enhance the chemotatic activity of neutrophil and T cell and basophil. It also activates the release of lysosomal enzymes from the neutrophil, and it is also going to increase the adhesion of neutrophils to the endothelial cells, because during inflammation, the neutrophils from the circulation should go into the tissues where the inflammation is. So for that purpose, endothelial adhesion is very, very important. So this interleukin 8 is going to help. And coming to interleukin 9, it acts synergistically with erythropoietin to support the growth and development of erythroid burst forming units. So burst forming units are the most immature form of hematopoietic cells in erythroid lineage. So the burst forming units will become colony forming erythroid units, and the colony forming erythroid units will become the earliest precursor cell called erythroblast or rubriblast. So interleukin 9 is very important, and it is committed to erythropoiesis. And coming to the interleukin 11, it acts synergistically with interleukin 3 to increase in size, number and ploidy of megakaryocytes. So interleukin 11 is very committed to megakaryocyte maturation and production. So ploidy means increase in number of nucleus, and as we also know that as the megakaryocytes mature, they do not develop like other cells. Instead, they mature in the process called as endomitosis. One cell becomes 2, 2 becomes 4, 4 becomes 8. It multiplies, and the cell size only increases as the number of nucleus increases. And when it reaches the megakaryocyte stage, you will see these bleb like structures, because these blebs will separate from the cytoplasm, and they will become the platelets that you see in the circulation. And in humans, interleukin 11 has proved to improve platelet recovery after chemotherapy induced thrombocytopenia in cancer patients. It's something very interesting you need to know. So that's it for today. Thank you so much for watching this video. I hope this video was informative. In next video, I will talk about in detail about erythropoiesis. Thank you.